Hello students, and welcome to your first day of doing a flipped classroom on your own. Two things to know about this presentation. One, for some reason my computer's being silly and some of these slides look really terrible, but I'll explain to you what's supposed to be on them and fix that. Two, I am not going to show you how to take notes today like I did on the last one where I told you to divide it up. This is kind of a note-taking diagnostic. I want to see what happens if I just tell you to take notes, and that way I can get a sense of where everyone is in terms of note-taking. So let's get started. In physics, we talked about using the metric system. Now, for every metric base, and you hopefully remember these from yesterday, the metric bases we normally use are grams, meters, and liters. For every metric base, there is a prefix, or a set of prefixes. So notice I have the word base right here. Talk about some meanings in a second. In order to tell how much of something we have, we use these prefixes. So if I ever have 1,000 grams, I use something like a kilogram. Kilogram is 1,000 grams. And you've got to be able to convert between kila and centa and milla and the bases and deci. So the point of the first part of this lesson is to teach you how to do that. First off, the bases start with these letters, K, H, D, B, D, C, M. And the way that I remember these bases is by saying King Henry died by drinking chocolate milk. So if you're ever on a test and need to convert metric units, you can go King Henry died by drinking chocolate milk and write down the first letter of each word, KHD, BDCM. What those letters represent: K for kilo, H for hecto, D for deca, B for base, so gram, meter, liter, D again for deci, C for centa, and M for milla. So now I want to talk about what each of these means. Let me clear off the screen real fast. So apparently the computer is not going to let me clear off the screen. Just all kinds of fun around here. So let's go through what each of these means. Kilo means 1,000. So if I have a kilo of something, I have 1,000. Hecto, 100. Deca, 10. The base is just whatever it is. So if I have a gram, I don't have to put any prefix in front of it. But if I have 100 grams, I would call that a hectogram. Then less than 1, so decimals now. We have deci, which means 1/10. Centa, which means 1/100. And milla, which means 1/1000. If you are at all not confident about your math skills, I encourage you to take the three fractions I just wrote, so here, here, and here, and somewhere in your notes, convert those to decimals. Convert the deci, centa, and milla to decimals. You have to know this chart to survive in physics because starting tomorrow I'm going to talk about kilometers, kilograms, kiloliters, decigrams, centigrams. If you don't know it, you will be lost. Look at this chart, ask questions of me, anything you got to do, you got to know this. So now let's try an example problem, or a few example problems. There are two key points to know when converting metric units. 1, if there is no decimal, put 1 in. 2, when moving a decimal, add a 0 if there is no number where you are moving to. This first question, A, asked me to convert 5,000 millimeters to meters. Well, first of all, I need to know what the metric prefixes are to do this. So I'm going to, at the top of my paper, write King Henry died by drinking chocolate milk. Okay? Now, when I convert millimeters to meters, the way I do this is I'm going to put my finger on millimeters, and I'm going to see how many places I have to move to get to meters. But wait, meters is not on here. Remember from the last slide that meters is a base, so I'm going from millimeters to the base. If I put my finger on millimeters, I go 1, 2, 3. That means when I come down here to the problem, put a decimal after the 5,000. Remember, if there is no decimal, put 1, key point number 1. And I'm going to go 1, 2, 3, and there's my answer. Okay, pause the video for a second and try the other two. I'll come back and let you know what happened or what the right answers are. All right, hopefully you've had a chance to try the other problems. I'm going to go through the correct answer. This one asked me to go from kilograms to grams. There is a decimal, don't have to do that. So I'm going to start at kilograms, go to my base, remember grams is a base, and it's going to be 1, 2, 3. Now notice this time I went to the right, whereas last time I went to the left. That's important. Since I went to the right here, I'm going to go 1, 2, 3 to the right. Now notice, second key point, when moving the decimal point, add a 0 if there is no number where you're moving to. So there was a number when I moved from between the 1 and 7 to after the 7, but then after that, I had 2 places without zeros. So I'll fill those in, and now I'll write out what I got. I have 1, 7, 2 zeros, and my decimal point at the end. So 1.7 kilograms is 1,700 grams. Now for some reason this next one throws people off, but all I'm doing is writing the problem backwards. So this one says go from centiliters to milliliters. Here's centa, C. Here's milli. I move 1 to the right. All right, now on this one I have to do both key points. There is no decimal point. I will put one after the 6. Now I move 1 to the right, leaving a blank space. A 0 goes there. So 60 milliliters is the same as 6 centiliters. All right, sometimes you'll be asked to convert units that are not metric, and for that you have to use what's called dimensional, hit the wrong button. You have to use what's called dimensional analysis. There should be an S at the end of that. Dimensional analysis. So here is just a fun example, not anything important that you're going to have to remember other than for the next slide. Let's say we have this thing called a jerk, and one jerk is 13 snaps, one snap is 6.6 crackles, and one crackle equals 1,000 pops. All right, we're going to solve a problem using that information, and this will be an example of dimensional analysis. All right, let's try this first problem. Convert 50 jerks to snaps. What I do here to start out the problem is first just write what I'm given, 50 jerks. Then I'm going to have to write what's called a conversion factor to multiply by. So this is called a conversion factor. And I need to get rid of jerks. This is going to work just like in math. So if I want to get rid of 50 times the word jerks, I have to divide by the word jerks to get rid of it. So my conversion factor is going to have jerks on the bottom, and then whatever I'm going to on the top. And from the last slide, we're going to 13 snaps. So now, I just check my dimensions. Jerks divided by jerks go away, and then it's 13 times 50, which is 600, I did it again, which is 650 snaps. So notice I eliminated the unit's jerks by dividing, and I was left with snaps. All right, the next problem says 9,000 pops to snaps. And for this one, I'm going to have to do 2 steps. I don't have anything on that slide that goes straight from pops to snaps. So let's start out. I have 9,000 pops. Remember, I start out with whatever I'm given, 9,000 pops. Then I'm going to multiply that by something that's going to get me closer to snaps. If you look back, scroll back a little bit to that slide, I see that one snap is 6.6 crackles. I also see that one crackle is 1,000 pops. So I could go from pops to crackle and then crackle to snap. Let's do that. All right, so I'm going from pops to crackles and then crackles to snaps. So from that slide, 9,000 pops, I gotta get pops on the bottom, and we had that 1,000 pops is one crackle. All right, now I multiply it out, boom, boom. Notice 1,000's on the bottom, so I gotta divide by 1,000. 9,000 divided by 1,000 is 9, so 9 crackles. And now I'm going to go from crackles to snaps, and I see from that slide that 6.6 crackles is 1 snap. Now notice, since, again, crackles is considered multiplied here, it's 9 times crackles, I got to divide, so crackles go on the bottom, and 13 snaps go on the top. Wait, I'm sorry, there should have been 1 snap. 1 snap goes on the top. I read it wrong. 6.6 crackles is 1 snap. Alright, now since I'm canceling crackles and crackles, 9 is divided by 6, and you should get about 1.4 snaps. So 9,000 pops is 1.4 snaps. Great. Alright, we're going to talk about converting things you might actually do, like inches to centimeters, yards to feet. This slide is only important in that it's going to be used later, so maybe just note on the video at what time this is, so if you need to scroll back to this slide you can. Also, my PowerPoint will be uploaded to the website so you can access that. Alright, this slide is also only useful in terms of being able to see the information on it for the next example, so note the time in the video in case you need to scroll back to this slide. Okay, using that information, I'm going to try these 2 examples. If you feel like you understand this, you might want to pause the video, try the example, and then come back and see how you did. First, I'm going to do example A, 3 feet 2 centimeters. So the first thing I will do is write down 3 feet. Now I'm going to go ahead and start abbreviating these. You'll pick up the abbreviations as we go. 3 feet, and I got to get to centimeters. Now on that slide, I had 1 foot equals 12 inches, and 1 inch equals 2.454 centimeters, but I didn't have anything going directly from feet to centimeters, so we're going to have to set it up in multiple steps. So remember, feet here is considered to be 3 times feet, so I've got to divide to get rid of feet. And on that page I had 1 foot is 12 inches. Notice whatever the bottom thing is in another unit, I'm writing it on the top. All right? And so let's go ahead and push this a little and do all 3 steps at once. 3 feet, 12 inches, 1 foot, and now I've got to go from inches to centimeters. So I want to end up with centimeters. That tells me centimeters has to be on top. I've got to have something times centimeters. And we had 2.54 centimeters in 1 inch. So if I do all the dimensions, feet will cancel with feet, inches with inches, and now I just got to do 3 times 12 times 2.54, which is 91.44 centimeters. And yes, I did pause my recording to use a calculator, so don't be frightened by that. Alright, I encourage you to pause the video and try example B, especially if you did not try example A, and when we come back, I will do example B for you. Okay, since I'm coming up on my YouTube time limit, I've written out the steps for doing this one. 1 day times 24 hours over a day times 60 minutes over an hour times 60 seconds over a minute. And when I multiply that out, I get 86,400 seconds. So check your math, check my math, see how you did. Alright, occasionally you are going to have to do what's called a rate conversion. This actually just means doing something with the top of the fraction and the bottom of the fraction at the same time. So let's say I wanted to convert 3 meters per second to kilometers per hour. Let's do that one. First I'm going to start out with 3 meters per second. Now I'm going to pick either meters or seconds and convert it. Let's go with meters. If you remember the metric chart with King Henry, kilometers is 1,000, so I want to end up with 1 kilometer, and there are 1,000 meters in a kilometer. Alright, so that's how I would convert the top part, and I can go ahead and do that. 3 over 1,000, so now I'm at 0.003 kilometers, and it's still per seconds. So now I've got to do seconds to hours. 0.003 kilometers per second. All right, notice for converting the time, I wrote my conversion factors on the top instead of the bottom, because when I cancel this out, seconds have to cancel with seconds to leave me with minutes. Minutes have to cancel with minutes to leave me with hours. So now I'm just going to do 0.003 times 60 times 60. And I end up with 10.8 kilometers per hour. Now this one's a little tricky. Maybe play that part of the video again, maybe try it yourself. Also, there's some extra practice on conversion on the website if you need it. This part is now scientific notation. I'm going to breeze through this because this was on your AP Physics homework, so you should know it. I'm going to do two examples. First, let's say I want to write 3,000 meters in scientific notation. In scientific notation, you're trying to get just one number before the decimal, so it's kind of like metric conversion. I'm going to pretend there's a decimal here and say 1, 2, 3. Sorry, I had a class start as I was saying that sentence. Scientific notation. I count how many places I have to move to only have one number in front of the decimal. And then I rewrite that number with whatever I got, so 3.0. And it's customary to go ahead and put a 0, so there are 3 zeros here. Obviously, if one of those numbers were like a 5, I would put that. But if there's not a number, it's customary to put a 0 for what we're doing. Times 10. And then for the power of 10, you're going to put how many times you had to move the decimal. So I had to move the decimal 3 times. So 3.0 times 10 to the third meters is how you write 3,000 meters in scientific notation. All right, we can also do it backwards. So let's say I gave you a number like 2.0 times 10 to the negative 2. So you're going to get two parts here to more bang for your buck. So this means, this negative 2, means I'm going to move the decimal to the left. Notice that the 3 here actually means I move it to the right. So if I wanted to go back, I'd go right 1, 2, 3, 1, 2, 3 to get to 3,000. So the negative 2 means to get to a regular number, I'm going to move the decimal 2 places to the right. 1, 2. And then my answer, oh, you know what I forgot to do? I forgot to do units. Let's say this was kilograms. So my answer now will be 0.02 kilograms. So notice all scientific notation does is makes the number so that the decimal is right behind the first number. I went through this really fast on purpose because it was on your AP summer assignment. I assume you did this over the summer and figured it out. If that is not true, there are some practice problems with this website post. Try those, get help from me or from Mr. Roosevelt or from Mr. Shar. We all know how to do scientific notation. Any of those three of us can help you. Other than that, you are finished. Be sure you've answered the pre and post or after reading questions. And that's it. See you tomorrow.